From river basin to open sea, this demonstration illustrates how European initiatives, WATERVERSE, CyclOps, and IDEATION work together to break data silos and enable true interoperability across water systems. By integrating diverse hydrological, environmental, and Earth observation data, the solution builds a continuous digital twin workflow where inland water processes directly inform ocean-scale models. Using the Aliakmon River use case, the demo shows how storm-driven plastic discharge is estimated through interoperable data pipelines and AI-enabled modeling, with results seamlessly feeding into the digital twin of the ocean for large-scale impact analysis. This end-to-end approach highlights how connected data spaces and digital twins can support better environmental monitoring, prediction, and decision-making, from source to sea. Access to the data portal of the water data management ecosystem is restricted to users registered with WDME. To log in, users must enter their credentials, username, and password. The data portal is organized by organizations. Each organization manages one or more datasets, and each dataset consists of one or more resources. Datasets are private, and access to their contents is protected via an API key. As a result, each user can view only the datasets they own, or for which they have the necessary permissions. In this specific case, the user has an admin role, and therefore has visibility over all datasets. Resources represent the actual heterogeneous raw data, and can be stored in various formats, such as JSON, CSV, Excel, and other equivalent formats. Data Mashup Editor is a tool within the water data management ecosystem that enables data pre-processing through a low-code, no-code, block-based programming environment. In this mashup, there are two input blocks corresponding to our data connectors, endpoints that when executed, retrieve raw data directly from the source. The first one is related to NetCDF precipitation data. The second retrieves data, shapefiles, related to the Polyphytos basin. The second step consists of converting the raw data into a FiWare Smart Data Model in JSON format and into NGSI-LD. As shown, the operator takes the raw data as input and outputs the same data converted into NGSI-LD. The third operator is a custom operator called clipping, which performs the merge of the two data sources. It takes as input the standardized data and returns the clipped precipitation data to the exact boundaries of the Aliakmon basin, still in NGSI-LD format. Once the merge is complete, we connect the output of the last operator to the output block, in red. To run the mashup, we navigate to the Flows section of the Data Mashup Editor. This section is structured into three main blocks. The first block concerns triggers, i.e. the definition of how the execution of the previously created mashup is initiated. In addition, a scheduled execution mode is available, which allows the mashup to be run at defined intervals, for instance every second, every minute, every hour, and so on. The second block is dedicated to selecting the mashup to be executed, including its specific version. The third block concerns targets, namely the destination to which the data in the output block will be sent once the mashup execution is completed. The results can be forwarded to an endpoint, e.g. HTTP, Kafka, etc., or if they are to be published to the data portal, the target parameters must be configured: name, address, port, and the user's API key. Since datasets are private, access to the data is restricted to authorized users, in particular, members of the relevant organization. In addition, the organization, dataset, and resource name must be specified. Once the flow has been configured, it can be deployed. After issuing the HTTP request provided by the mashup editor to the endpoint, the mashup is started and executed successfully, and the resulting data are saved within the CyclOps organization, in the selected dataset, under the previously specified resource name at the WATERVERSE data portal. Moving to the CyclOps lab, which is a Jupyter Lab environment with Alira, MLflow, and MinIO all wired together. We are going to run a 5-stage hydrology digital twin live and show you where the data, the models, and the artifacts land. More specifically, the pipeline is a simulation of Aliakmon River basin. It ingests hourly precipitation from the WATERVERSE data portal, converts rainfall to runoff with the SCS curve number method, passes it to the outfall to build a hydrograph, and adds base flow and pollutant loads, given an hour-by-hour picture of flow and water quality at the sea. Now, for the creation of the pipeline, we press the generic pipeline editor of Aliakmon and drag and drop all our Python files into the canvas. After that, we are making the connections between the blocks. We have to set up a runtime image for all the blocks. Now the pipeline is completed. It has 5 stages. First, we fetch the data from the CCAN data portal through API request. Secondly, we compute effective precipitation with the SCS curve number. Thirdly, we route the runoff cell by cell to the outfall. And then we add base flow and pollutant loads. And finally, we push the artifacts to the ML flow and the min.io. Let's execute the pipeline. First, we have to save it, and then click Run Pipeline button. We will choose Run in place locally, and we have set the name of the pipeline. We have to wait for a while in order to be completed. And now the pipeline has been completed successfully. Now if we open min.io, we see that all the artifacts from all stages have been stored here. Nothing is thrown away, so any stage can be rerun or audited independently. Next, the ML flow tracks each runoff every stage with the included parameters, metrics, and tags. Stage 5 logs the published metrics, for example. Here you may see the results, and also we have some plots. Finally, Stage 5 pushes back to the data portal the final output CSV files. So the result is immediately visible to downstream users, not just inside CyclOps lab. Building on the outcomes of the previous stages, these results were integrated and further leveraged within the Edito ecosystem to reuse them in the digital twin of the ocean. So the intent is to do a plastic transport simulation, where we use the results from the Aliakmon River mouth. We have the values of flow and concentration of plastic, and we perform the simulation with the elements we have on Edito Model Lab, which are the Surf-Shythem application and Medslick 2 embedded in WIT-Oil Cloud. So the idea was simply to go into this in the mouth of the river Aliakmon, get this discharge and the concentration, which come from the previous processes, and use these elements that are available in Edito to do the modeling. So here we have the grid in which we run simulation, in a way that we could compare these same results with Copernicus marine Mediterranean sea currents. Here on the left, we have the Copernicus downloadable dataset, and here we have the Surf-Shythem results, the downscaled approach. You can see even the velocity and the river mouth, not only Aliakmon, but the other river next to it. And then from these hydrodynamic forces we were able to generate the concentration results of plastic, so we can follow how is the concentration being measured over time, and when we can watch the differences, either in this concentration. We also have the trajectory, so we can check the same, but this time using particles instead of concentration. And finally, we also have the mass balance, so we can compare how both simulations presented the budget of the plastic in the area. So for example, we can see that downscaled results, they have more plastic available in the water surface rather than the Copernicus dataset. So this implies and shows all these two tools available on IDEATION can be merged with other digital twins, and that results will differ because they are also different technologies. Thank you for watching this demonstration. For more information or to connect with the project teams, please scan the QR codes or visit the websites and social media channels shown here.